In today's video, we're going to talk about bond energies and understand how they help us figure out whether a chemical reaction will give out energy or take it in. When we talk about bond energy, we are actually talking about the amount of energy needed to break one whole set of a particular covalent bond between atoms. Imagine a hydrogen atom joined with a chlorine atom forming hydrogen chloride. To break that bond, we would need to put in energy. In simple words, bond energy is the measure of how strong that bond is. The stronger the bond, the more energy we need to break it apart. Now, whenever we break chemical bonds, energy is absorbed from the surroundings, which means the process is endothermic. The reaction takes in energy because the atoms need that energy to separate from each other. On the other hand, when new bonds are formed, energy is released to the surroundings, which means it is exothermic. So, if we were forming hydrogen chloride, again, the same amount of energy that was used to break the bond would be released back as heat. Let's take a simple example. If hydrogen gas reacts with chlorine gas to make hydrogen chloride, we first need to break the hydrogen-hydrogen bond and the chlorine-chlorine bond. Both of these steps require energy and are endothermic. After that, two new hydrogen-chlorine bonds form, and these steps release energy, which are exothermic. To know whether the whole reaction is exothermic or endothermic overall, we compare the total energy taken in to break bonds with the total energy released when new bonds form. If the energy released is greater than the energy absorbed, then the reaction is exothermic overall and heat is given out. But if more energy is absorbed than released, then it becomes endothermic and energy is taken in from the surroundings. In exams, you are usually given a list or a table of bond energies. You just use them to calculate the overall change. You add up the energy needed to break the bonds and subtract the energy given out when new bonds are made. If the result is negative, it means the reaction gives out heat and is exothermic. If it is positive, it means the reaction takes in heat and is endothermic. So a negative value tells us that the chemicals are losing energy to their surroundings, while a positive value shows that energy is being absorbed. Now, let's look at another example that involves nitrogen reacting with hydrogen to make ammonia. To understand it clearly, it helps to draw out the molecules so that you can see the bonds. On the left, we need to break one nitrogen-nitrogen triple bond and 3 hydrogen-hydrogen bonds. On the right, we form 6 nitrogen-hydrogen bonds. When we add up the energy required to break the bonds and then subtract the energy released in forming the new bonds, we find the total change. The result in this reaction is negative, which means it gives out energy overall and therefore is exothermic. The main idea to remember here is that breaking bonds always takes in energy, while forming bonds always gives out energy. The difference between these two amounts tells us whether a reaction releases heat or absorbs it. So, by using bond energies, we can predict if a reaction will warm up its surroundings or cool them down. This is why understanding bond energies is so useful in chemistry, because it lets us explain why some reactions feel hot and others feel cold.